So, hi everyone, my name is Aristides Fernandez and I'm a Senior Partner Solutions Architect working in AWS. I work directly with Accenture. I cover the Iberia and France region. I've been in AWS around 2.5 years and I'm very excited to be here for the first time in OpenSlava, joined with my colleague Stefano.
All right. So, hi everyone. I'm Stefano Boscolo, and I'm also a Senior Partner Solutions Architect at AWS. Since I joined AWS almost 3 years ago, actually, I've been part of the so-called AWS Accenture Business Group. I look after a couple of market units. One is in Italy and the other one in the Middle East. And I'm also quite excited to be here despite the technical issues. So, Ari, do you want to take over?
So thank you very much. Today we will talk a little bit about how AWS is trying to simplify the generative AI development. Specifically, we will talk about how we are developing this in an Amazon Bedrock platform. Okay, but first we need to understand what AWS is offering around this generative AI, and to build secure and reliable generative AI applications, you need a lot of capabilities. And what AWS is trying to do or is doing is splitting this in 3 layers. You have the first layer is the infrastructure layer. This is where you have the performant and cost-effective infrastructure. So if you are very skilled machine learning data science company that wants to build your own model, this is where you can use performant and cost-effective chips. Okay, if any of you know, Amazon produced their own chips for training and inference, but they also have the capability to use NVIDIA's GPUs or any other GPUs in the market. That wrap up with SageMaker, which is the service that we use to manage all this infrastructure and train and fine-tune this model by the specialized team. Then we move to the middle layer. This is the layer where you can very secure, privately, and easily build scalable and powerful applications, okay? And this is where you can leverage big foundational models in the market. And this is our Amazon Bedrock platform. This is where we will talk a little bit today about all the features. And at the top layer, you have the application layer. This is a generative AI application that allows you to support your development and software lifecycle, but also leveraging your data infrastructure within your company. Okay, I see a few of you that were yesterday in hands-on. We actually did a hands-on lab on Amazon Q. But today, we will focus on the middle layer in the Amazon Bedrock features. So a few capabilities that we want to show is, with so many models available right now, model evaluation is very difficult to perform and very tricky when you are building your use cases, okay? And evaluation allows you to use automatic or human evaluation, or Amazon evaluation allows you to use automatic or human evaluation performance, right? So with automatic performance, you have a predefined data sets already there for you with a specific metrics like robustness, toxicity, and this kind of metrics where you can evaluate different models that you want to use. And you can do this in the playground, as you can see in the slide. The playground is basically in the console of AWS. You can test different models right away when you are building your use cases. But you can also do it programmatically. When you are in the software lifecycle already developing, using the API and your code and everything, you can invoke the model evaluation to test different models when you have already your use case. Then we have subjective criteria, right? When you want to make specific metrics around your brand voice, or around your relevance or your style, this is where you can leverage your own team of reviewers, or you can use AWS managed reviewers that allows you to make these custom metrics and data sets for your model evaluation strategy. This is already generally available for you. The next one is Amazon Bedrock Prompt Management, okay? And this is a new feature that we released a few weeks ago. And prompts are the instruction that we send to the generative AI application, and it's a very challenging tasks to deploy these prompts, right, for different use cases and different models. So this foundational model has significant challenge, and it can take weeks to do this. And sharing this across organization can be very, very, very difficult. So Amazon Bedrock Prompt Management basically allows you to build these workflows, enabling you to create it, sharing, and compare version between these workflows. And you can collaborate in a single pane of glass with other teams. And once you have your prompt, you basically can make variants of that prompt with other teams within your organization. Of course, the natural flow of this is that once you build your prompt, what you want is to have the output of one prompt to be the input of the other prompt, right? You want to use this as a variable that can build your logic and your workflow. And this is where we include prompt flows a few weeks also back. And this is where you can leverage prompt flow to actually create, test, and deploy all these logics that normally are very complex to do, right? You have this integration. It's not only prompts output that you need to integrate. You need to integrate guardrails. You need to integrate different models. You need to integrate also knowledge bases, vector databases, other AWS services. And this, in an easy way, drag and drop visual-based interface, you can build all this logic and test it right away. You have even different deployment options like blue-green deployment, A/B testing, and all these functionalities right away in the console. And another one that is really been there for a while is Amazon Bedrock Knowledge Base, right? And I see many of you probably already working with the generative AI. So RAG is one of the techniques, retrieval augmented generation, that we use to minimize hallucination, to leverage our proprietary data within our company. So basically, knowledge base for Amazon Bedrock is a end-to-end managed RAG system. Okay, so we manage from the ingestion, from the vector database, from the embedding model, from the enrichment of the prompt, and from the final prompt response. We manage everything. Orchestrating this with line change or any other orchestration framework can be challenging if you don't have the skills to do that. And basically, we're doing everything for you in this case. Okay? One of the things that we realize is that the data source from the customers are really important. And until a few months ago, we only support Amazon S3 or data lake services, object service storage to ingest data to knowledge base, to the vector databases. Right now, we're including Salesforce, Confluence, and SharePoint with web crawler to ingest directly data from those SaaS applications directly to your vector database knowledge base. Okay, so for example, if you want to do a claim for an insurance company directly from extracting data from Salesforce, you can do that and then enrich your services with your policyholder, for example. And with that, I give the time, Stefano, to follow up.
Thanks, Ari. All right, so Ari already introduced some of the key concepts with Amazon Bedrock. We have another important concept that is becoming more and more important. I remember that, we first started talking about GenAI. Most people, they talked about prompt engineering, then RAG. Someone was doing fine-tuning. Now what we see is that agents are actually becoming more and more important. Why is that so? Well, in most use cases now, you have different data sources. You may have, some data, let's say, in a SQL database, like some other data may be in an S3 bucket or in a NoSQL database, and you need to coordinate all these different data sources. Another problem, another issue is that, some actually tasks are quite complex. And by quite complex, what I mean is that these are multi-step kind of process. And for that reason, we implemented a feature called Agents for Amazon Bedrock that basically allows you to implement these multi-task steps with large language model, and you can, of course, coordinate with multiple data sources. So it works in a very easy way. You start selecting your foundation model. You provide some basic instruction, even using the AWS console. You select the relevant data sources. These could be, let's say, an S3 bucket. It could be, I don't know, a NoSQL database, and so on. And then you specify the actions that you want your agents to perform. This usually means, if you're already familiar with AWS, that you need to configure few AWS Lambda function. And agents, what they do, they orchestrate all these complex workflow for you. A good thing that usually developers really like is to troubleshoot, right? Because things can go wrong. And that's the reason why we are providing insights into the chain of thought trace. So you have the ability to check what's going on with the prompt, and also to modify the agent on the fly. This summer, we launched a couple of new features for Amazon Bedrock agents. The first one is code interpretation. Now, code interpretation basically allows your agents to dynamically generate and execute code snippets within a built-in sandbox, which is, of course, secure, and it can also help with complex use cases when you need to generate some code, for instance, let's say a few lines of Python. A great thing about code interpretation is that actually it can generate some charts and analytics using the code. It usually, a few lines of code in Python, and it can automatically analyze different formats such as CSV, JSON file, PDF, TXT, and more are coming. Another thing that I wanted to mention is that we also implemented recently this memory retention function for Amazon Bedrock agents. Now, agents, what they can do, it can retain memory across different interactions. And this is very helpful because with memory retention, you can build an agent, say, and the agents can learn and adapt to your user's request, and then it can keep the session over time. The way it does that is by using a unique ID. So there is an ID, and this ID is, of course, distinct for each user request. And this is another important feature of, I would say, Amazon Bedrock with agents. Now, Aristos, you would like to take the next part?
Yeah. So another feature that we include very recently, a couple of weeks ago, was a cross-region inference, actually. And basically, cross-region inference is no more than the ability to invoke the model from any other region plus after your source region, okay? So basically, we have introduced what is called the inference profile. And basically, the inference profile is a profile per model that you have attached with different AWS regions available. So we have abstract all the complexity around the routing and the transfer of data between one region and the other. And now with just one inference profile ID, you can invoke these inference models from different regions, okay? And this is very helpful because it enables you to seamlessly actually route the traffic for fault tolerance from one region to another. And the key things here is that sometimes when you are on demand mode using Amazon Bedrock, so when you are trying to inference the model in on demand mode, you have some quotas there, right? So sometimes you will reject it. And we automatically will be able to route that to a second region and allows you to maintain your data and your application live for your customers. The other thing about this is that it not cost anymore. It's not any other cost on top of what you're already paying for your tokens. So the routing and the data transfer is already, it's free for you. We only charge for the price of the token from your source region, actually, and not for the other region that you are using. And another thing is that we have inference profiles based on regions. So for example, if you are in the European Union, the inference profile with the regions that you can reach as a fail out is within European region. That means that you can maintain your data residency, your compliance, your standards, and everything on your application. Let's try to look at how this works. So basically, you can have region 1, that's your source region, the region that where you build your application, and let's say you have a second region with the double of capacity. Normally, you can go up to 2 times the capacity that you have in your own region, in your source region. So you will have different requests from your customer. Let's say that the first request is accepted, the second one is accepted, but then because you are on demand, the third one it's blocked because of capacity constraints or maybe latency, right? So we route the traffic to the second region automatically. So it's not a load balancer. Okay, we try first with the region 1, and if the region 1 is not getting the right performance metric, then we fall back to the second region. So it's not load balancing this. Okay, so we reroute the traffic to the second region, and then we respond back to the customer. For the customer or the client using the application, this is seamlessly. They don't get any error or anything. And for you, you are not paying anything more. Okay, so this is a functionality out of the box to build high resiliency, high available application, which if some of you are infrastructure technicians or architects, can say that it's very difficult sometimes to build these high resiliency, high available applications, specifically with generative AI. Okay, so we had prepared 2 demos. Let's see if we can do it because we have some time constraint. I will try to share my screen very quickly, if I can do it.
Well, you can do it.
Yeah.
Yeah,
Here.
amazing.
Here, can you see it? Very good, or?
Yes, it's good.
It's very, yeah. Okay, I have a notebook here. Let's see if I can open the notebook. Can you see it, actually?
Yes, we can.
Yeah? Okay.
It's a lot of code.
Yeah, it's some APIs. So here you see the first API that you have is the list inference profile API. So basically in this API call, what you're looking is all the inference profile that you have in your account available right now. Okay? So if you see here, you can see some Claude 3 Sonnet. And you, for example, here you can see, I don't know if you can see my pointer, but you can see that EU Central 1, EU West 1, and EU West 3. That means that you can reroute your traffic from Frankfurt, London, or Ireland. So if your source is Frankfurt, then you can fall back to London or Ireland region. Okay? This is the list profile API. Then you have a get instance profile API. This is where you want to understand a specific model's inference profile. Here you can see if the model is active, which routes you have, and the model ID and the ARN. Okay, this is the identifier that you can use to invoke the model with your APIs, with your inference API. So here in the next part, I will go a little bit faster. This is the Converse API. So Amazon Bedrock supports Invoke Model API, which was the initial API that we released, and now we support the Converse API, which abstract a little bit all the parameters that you have to configure based on the models. And here, what you can see is we are passing a prompt, right? We have the model ID. This is the foundational model, your source region, and then you have the inference profile ID. You can see it here, right? So we are measuring the time between one and the other. And you can see that your foundational model have 9 seconds. This is the response. And then you have your inference model here, it's 5 seconds. So actually, your second region is better performant than the first region. And we will do the fallback directly from one to other based on your thresholds and your traffic patterns that you may have for your application. So this is automatically, and this is using the Converse API. You will have the same with the Invoke Model API. You can see that the Invoke Model API have some parameters that you have to configure, but this was the first API that we released for Amazon Bedrock. So many of our proof of concept and production environments have already deployed with this API. And you can just still use Inference Profile ID to fail off with this API. So you can update your new application with this Model ID identifier and just use the out-of-the-box cross-inference, cross-region inference feature that we have received. With that, Stefano, I think we managed to do it.
We managed to do it, at least the first demo. We'll see with the second one.
Here. Good.
Oh, wow. Amazing. All right, now I have this one. All right, let me see. Maybe I do this one.
No, it's not.
That's not working?
That's not working.
Oh, okay. Amazing. Okay, so let's talk about how you can safeguard your application using Amazon Bedrock. I also remember, that a few months ago, just a few customers actually cared, about how to safeguard the applications. Because, at the beginning, the focus was all on POCs, building POCs. Then, customers wanted to actually go, some customers at least, on production. And now, especially for the applications that are public-facing, they are starting caring about responsible AI, which is becoming more and more important, especially in the public sector, by the way. So that's the reason why we built these features called guardrails for Amazon Bedrock. What customers now want is to avoid let's say, undesired content, or even, avoid irrelevant, toxic kind of the discussion. They also want, to make sure that, let's say, users are not engaging in any, let's say, harmful interaction with the GenAI application. And something that is also very important, especially here in Europe, is dealing with sensitive information, right? Especially, for GDPR reasons, but not only that. So we also want to make sure that, our personal data or PII are protected. And basically to address, these challenges, many models providers, actually all of them that are in Amazon Bedrock, they have already built in these kind of protections, right? Some safety. But, still challenges may arise because, some customers, maybe they want not to focus on one large language model, but maybe they want to try more large language models, right? And if they want to try more large language models, an important thing that we need to maintain is consistency, right? So we want our safeguards to be consistent across different large language models. And also, some organizations may have, let's say, specific guidelines or regulations, and they may want, for instance, to have some topics that need to be denied, that are specific in the organizations, and they cannot find this in the foundation model. Of course, you can always prompt engineer that, right? But prompt engineering also comes with a cost. And this is where, guardrails for Amazon Bedrock can come into your help, because you can define custom safeguards specific to the organization's need, regardless of the model that you are using. So this slide explains how, guardrail works. It basically will take, the user input, and before even sending it to the large language model, the input will be reviewed. And this is invoked by, let's say, either a Bedrock invoke model API or through, an independent guardrails API. It will then be scanned, as you can see, across multiple components of the guardrail. And if any of these get triggered, the prompt will not be sent to the inference point. And instead, it will be, let's say, either replaced with something, with a predefined response or with something else. And of course, if the prompt passes the guardrail, the same checks are done for the model response. Recently, we introduced a couple of, I believe, very good they in Amazon Bedrock for guardrail. The first one is contextual grounding checks. So, of course, customers, they are starting relying on the capabilities of foundation models to generate, content that is actually credible, right? Which is true. But the problem is, of course, that we all know that, right? That foundations models sometimes can conflate multiple pieces of information generating hallucination. And that's the reason why we introduced this contextual grounding, because, it can help with hallucination. You can set up a threshold, which is basically, a number between 0 and 1. And you can basically understand if the response of the model is grounded on a specific context that you can define. And imagine that this context could be, for instance, the some enterprise data, for instance. It will be then checked. It will return a score in a JSON file. And, you can decide the behavior of the guardrail. You can mask an information, you can deny the topic, and you don't even, you don't always check for grounding. You can also check for relevance. So you have two different things. You have grounding and you have also relevance. And a good thing, especially for those of you who really like to customize models and play around with the custom models, it's these new features, which is called the Apply Guardrail API. Now you can use guardrails with models that are not necessarily on Amazon Bedrock. They could be deployed, for instance, using Amazon SageMaker, which is, our data scientist service, or even, hosted, let's say, somewhere else, maybe on an EC2 instance. But you can still use the Guardrail API, which is basically separated from Bedrock. And this is actually a quite cool feature, especially for some Accenture folks that I know they like to play around with the custom models a lot. By the way, this is not useful only for generative AI, of course. This can also be applied for, let's say, traditional machine learning model, even though I don't really like this word that much. Let's see if I can, I don't know if we have time actually for the demo, because we only have 10 minutes, and we still, maybe want some questions, right? So let's see. Let's go on. If there are not enough, questions, or we have some time, we will show you a demo of how Guardrail works. Because there is, we have still a few slides, some cool features that I wanted to mention. The first one is Amazon Bedrock Batch Inference. Now, batch inference allows you to do several things that you can see in the model, in the slide. Let's say that you have a very large volumes of data, right? And as you probably know, if you want to send a large amount of data to an API, you could have throttling issues. And of course, you don't want that. So something that you can do is instead to use this batch inference API, which means that you can basically take a bunch of documents or data, send it to the inference endpoint, and have a kind of batch interaction, which of course, I mean, as usual in IT, batch inference is not useful if you want, you know, a real-time or near real-time response, but if you need the process to be batch, that's very good. Also, you can get, you know, a pretty good discount because, I mean, the price can be up to 50% lower compared, let's say, to an on-demand inference. And as I said, it's well suited for when you have a large amount of data. You can think, for instance, when you have, let's say, I don't know, a call center, and you want to analyze some of the transcript from the call center, you can send all this information in one go to the batch inference endpoint. This is how it works. It's very easy. You basically select a model, then you prepare the data. You need to have, you know, a JSON file that specifies some key information about the data. You upload this data to an S3 bucket. Then you create a batch job. This can also be done either with the CLI, or, you know, if you don't like the CLI for whatever reason, you can always use the console. And then, you know, after the batch inference is done, it will collect all the output in an S3 bucket. This is just, you know, to summarize. I believe it's quite important. I mean, when working with generative AI, you have different models, so you have different, you know, types of inferences. So it's always, you know, useful to understand which one should I use for which use case. And choosing the right strategy, it's of course very important, and it can also, you know, save you quite a lot of money, actually. So batch inference, as I said, very good, you know, if the volume of data is quite high, but it's not really suitable, you know, for, let's say, real-time or near real-time use cases. Then we have on-demand. On-demand is probably, you know, it's very good, you know, if you want, let's say, to run a POC, and you have the usual kind of, you know, pay-as-you-go model, right? It comes, of course, with some cons, which is, you know, in the on-demand inference, the resources are on a shared tenant, right? So some customers may not like this. Latency can also be higher compared to other, you know, kind of types of inferences. And also, it does not support customized models. So let's say that you all want to fine-tune the model. You start from your, you know, foundation model. You want to fine-tune it. On-demand kind of inference is not supported for custom model. If you want, you know, to customize your model, for instance, fine-tune your model, you should go for a provision throughput kind of instance. This is good, you know, for running in general, I would say, a consistent production workload. And it has the ability, of course, to process workload at scale and with speed. But, you know, as you may imagine, since, you know, this is for production, it can also be quite costly, right? So don't use it, you know, if you want, you know, to run a POC and to show something to the customers. Use it only in production. And finally, you know, as Aristides said, you know, we have a cross-region inference, and Aristides, you know, already, you know, explained very well how it works. You know, it has, you know, you have different regions, and basically, you know, you can call all these different endpoints and kind of, you know, reduce the burden on your latency, as Aristides showed in the demo. Let's see, you know, if we have some questions, and if we don't any, if we have just a few, we will try to see.
We have some questions.
Oh, okay, we do.
Yeah.
Okay.
So the first one, very easy, yes. So everything is managed by AWS. You only need to use, instead of the model ID API identifier, sorry, for the foundational model, you use the inference profile ID. And that automatically will have the cross-region inference feature available for you. So we manage everything, the routing, the transfer, all of that.
Well, the second, I guess, is for me, how do you filter out denied topics? How do you identify in a large context a denied topic? Well, this is something that I'd like to show you actually in a demo. I don't think we will have enough time, but if you're interested, I can show you later. But basically, in the dashboard, in the AWS dashboard, what you do, you define a topic, just giving it a name, and then you have to give like a clear definition. The prompt that you send to the large language model will be basically checked against this denied topic. So just to give you a very simple example, let's say that I work for, I don't know, BMW, okay? And I don't want that my chatbot mention, I don't know, a name of whatever, Chrysler, okay, for whatever reason. In that case, what I will do, I can create a denied topic and state a very clear definition about what this topic is supposed to be. So I will say something like, don't mention, other cars in the competition, especially Chrysler, and so on. And you can define, of course, many multiple, denied topics.
If a company wants to implement an AI assistant, what would the cost be with AWS? Maybe 50, 100 site visits per day? Well, that's an interesting question. We actually cannot answer that here. We need to understand the use case. It depends. We have more than, in SageMaker, more than 100 models, and in Bedrock, we have more than 20 models available. So it depends on the time of response, the use case that you need. The cost can vary a lot. So I would suggest to reach out to your PSA, Partner Solutions Architect, or account team, and we can work with you on that. Okay?
But Ari, if I can say something, there is something that we can say. That, the price of the large language models, and I was about to write this, but I'm very slow at writing, it depends on several things. So it usually, the token that you have in input, the token that you have in output, right? So, it all depends. If you have, let's say, 50, invocation of the model with like a kind of a standard prompt, it doesn't really cost anything, right? It could cost just a few dollars. It also depends, though, on the kind of model that you use, right? Because in Bedrock, we didn't say that, but we have many different models. Models from Meta, from Anthropic, from AI21 Labs. We have many startups in Bedrock. So it also depends on that. But I would say it could cost, generally speaking, a few dollars, right? If you have like 50 prompts, but
if you can say that.
But it all depends, right? Depends on the context window as well, right? If you have a very large context window, so.
Okay, next question. Can I play with this individual for free? Yeah, you can open an AWS account. Basically, the playground that we mentioned in model evaluation, you actually can test the models, like every model. Of course, if you want to invoke in your application, you then will have to be able to pay for that. But if you want to test it locally, you can do it right away, for sure. Next one.
Does batch inference allow agent interaction? Yes, agent can also manage the batch inference. So the short answer is yes. This one was very, very short.
I think you discussed about this. What is the price difference of batch inference versus real time? At least one example.
Well, no, about the price, I didn't say, I said generally speaking, I know that there is a difference in price depending on the use case, but I didn't say anything about price. I don't have, figures in mind now, but what you can do, if you go to the AWS documentation and write Bedrock AWS documentation on whatever kind of, research engine that you like, you can find, the prices with actually real examples. So I would suggest to go there.
Next question, can you combine provision throughput with other options? If, for example, there is an overflow of requests, can those be direct to on-demand option? yeah, absolutely, you can do that. Actually, this is one of the use cases that we do, for example, with Amazon Connect, which is our contact center as a service. So when we measure or we dimension the solution to be on demand on the not peaking hours, and in the peak hours we use provisioning throughput to maintain the latency that we need to do the translation or whatever use case that you are using for the contact center. So yeah, you can fall back between one provisioning throughput and on-demand throughput in our services.
The last one, I think, is still for you because it's about monitoring model.
Yes, for the automatic one, yeah, we have the data sets with some prompt, also with benchmarks and specific metrics. So if you want to have custom metrics and a specific data set, that's where you have to go to the human intervention evaluation. But automatic ones, we provide data set, benchmarks, and all these kind of things for you right away in the system. I think with that, we don't have any other questions. Thank you very much for listening. There is some sticker here if you want to grab some, and thank you for taking the time being here. Yes. Thank you.
And by the way, I know now that there is a break, right? But if some of you, for whatever reason, would like, to see how the demo works, etc., we are here. If you want to enjoy your break, of course. But if you are interested, you can come or stay, and yes, we are still here for you. So.
And don't forget the feedback.